Hello everyone. So here is a brief agenda for our webinar today. We'll basically be looking at connector definitions inside Revit and see how the connector definitions work together to propagate flow through ducts and pipes. We'll then see how we can utilize some of the analysis tools that are available within Revit to make sure that our system is connected correctly and the flow is propagating. We'll then see an application of the schedule for the system and see how the schedule can be used to also view the flow and analyze your system. And we would finally be discussing upcoming events with CTC, followed by any questions you may have. All right, so with that, let's begin the presentation. And what I'll do is I'll jump into this model that I have open inside Revit. And before we get into that system, what I would like to show you is just the basics of how the system works together. And I have open in front of me a project that was started with the systems template. So the systems template, if you're familiar with the out-of-the-box template, has got views predefined for the different electrical levels. So you've got lighting and power views, and it has a mechanical view available and also a plumbing set of views available in it. What you'll also see in this template are some families that are preloaded, and we would be using some of these families and then getting into the connector definitions for these families to see how the flow works together within these families. So to begin with, what we'll do is we'll start with this linked model here. So I've brought this linked file in, which again is a sample file available with the Revit install. And this is the linked model that you would see if you were to bring this inside your project. And I'll go back to my one mechanical floor plan view. And I'll start by placing some diffusers in this view. So diffusers will be found on your air terminal button, and you can select among the different sizes for your diffusers. So for this particular family, we just have one size, a 12 by 12 face with a 12 by 12 connection on it. And you can choose if you want to see the arrows on the connector or not. If there are available flow values for the space, then you can either manually adjust the flow for each diffuser, or you could use a tool like Spreadsheet Link to automatically calculate how much the flow should be for each diffuser and tell that to you, so that the flow that you specify for each diffuser exactly adds up to the flow that is required for that space. So we had done a webinar on that as well, so feel free to check out our YouTube channel and find that information out there. So I can specify a flow here, and I can also specify a pressure drop here, and these values would typically be coming from the manufacturer for these diffusers. So you put those values in, and you also specify an offset before you place your diffusers. So let's suppose we place them at an 8 feet offset, and I can just drop in a few diffusers here. So you can see that what the program does is it automatically adds a tag to tell you the flow, and it also puts in an instance mark property for your diffusers. So let's suppose we have 4 diffusers needed in a couple of these spaces. Right, so once our diffusers are placed, what we can do is we can then see that there is this little exclamation mark showing over here. And if you click on that, it tells you that the element has an open connector. So this is a very useful tool to have running, because it will allow you to see any open connections in your systems. And the way you can turn it on is on the Analyze tab. If you go to Check Systems, you will find a button called Show Disconnects, and you can just click on that. And you can see that I have the duct option selected here, and that is what allows me to see any disconnects in the model. Now Autodesk recommends that you do not have this show disconnects button running all the time, because it is something that could affect the performance, because Revit has to always keep track of all the disconnects with this tool running. So what you could do in that case is, if you are having any performance issues, is you could just turn this on, quickly look for any disconnects, turn it off, and then rectify your model. All right, so for a simple model that we are looking at right now, we don't see any great performance lag here. So we'll leave that button on. So we have these diffusers that are disconnected. And another tool that you can use to analyze your systems as you're creating them is called the system inspector. So there are a couple of ways to bring up your system inspector. One way would be to go on the View tab and under User Interface, find your system browser. So the system browser can be brought up this way, or you can hit the F9 key on your keyboard and also bring that up. And the system browser would also dock right beside your project browser. And right now it tells me that there are 8 unassigned items in my system. And our goal here is to reduce the number of unassigned items in the system browser and get them to automatically filter into the mechanical or piping systems. So the way we do that is by adding more equipment as part of the system. So what we could do is we could go to System, go to Mechanical Equipment, and these are some out-of-the-box families that are loaded inside this project because they are also loaded inside the template. And let's suppose we go with a VAV parallel fan powered unit, and I could go with the size 2 with an 8-inch inlet. And again, before placing your VAV, you can specify an offset value, and you could also specify the pressure drop for your VAV. This again would be based on what values are specified by the manufacturer for the pressure drop as the air leaves that VAV. The supply airflow is set to a default value. What we will see is once we connect our diffusers, the supply airflow should automatically populate to reflect the number of diffusers it's connected to and how much each diffuser is throwing out. So at that 10 feet offset, let's suppose I place my VAV out here. Right, and again we have the tag on placement selected, so it automatically tags the instance mark on the VAV. And let's have another VAV here. Right, so with our VAVs in place, what happens now is this VAV, I have placed just 2 of them, but you must have noticed that the number of unassigned systems has gone up from 8 to 14. So the reason you have 6 more unassigned items is because of the number of connectors that we see on the VAV. So the VAV has got a few duct connectors on it, and it has also got an electrical connector on it. So we have all these additional connectors, and they also contribute to the unassigned items that we see listed over here. So we will see some of the items go down from the number of unassigned items, but you will still find some unassigned items because our goal here is to just work with the mechanical connections and not really looking into the electrical connections at this point. So again, we see the icons here indicating that we have open connections. And what we can do is before we even make these connections between the duct and the between the diffusers and the VAV, what we could do is we could have a system created. So the system could be created automatically either by just drawing the duct, or you could explicitly create the system first and then draw the duct. Okay, what you could also do is have Revit automatically draw the duct for you, but we have seen mixed results with that kind of a workflow. And it depends on the kind of layout you select and also the elevations. So there are a few variables that dictate whether you get a successful automatic duct layout or not. So what we'll do is we will eventually route the ductwork manually, but before we do that, we'll just create our systems. And the way you can do that is by starting at the diffuser and creating a duct system. Right, you can give your system a name. So this name could be based on the room that it is servicing. In this case, we'll just go with that default name of supply air 1. And what we can now do is we can add the other diffusers to that system. So you can add them by just doing a window selection around the diffusers. And what you could also do is before you exit out of the system, you could select the equipment that is going to be supplying the air to these diffusers. And that can be done through this drop down. Now we can see that we have 2 VAVs placed and we haven't assigned a unique name to the VAVs. So there's no way for us to identify which one is the one we want to use. So instead of using the drop down, what you could then do is just click on select equipment and then it will tell you down here to select the equipment serving the system, and we can now explicitly pick this VAV here. So once that system is created, what we would see on the system browser is that the number of unassigned item automatically goes down from 14 to 10. So this is getting to our goal of reducing the number of unassigned items in your system browser. So once your systems have been assigned, what you can then do is you can route the duct to manually connect your VAV to the diffusers. So let's go to duct now, and with the duct tool selected, what we'll do is we see that the duct that is being used is a 14 by 14 size, and the offset is at 9 feet. So I can pick the connector in this way. As you hover over the VAV, it tells you the connection point, it gives you the connector description, and it tells you that the connector is a 14 by 14 connector at a 10 feet offset. So what you could do is you could either manually put in these values here before you route the ductwork, or you could use the inherit elevation or inherit size buttons. But what I'll do instead is I'll click on the connection point here, move my duct a little away from the VAV, and I'll just hit the spacebar key on my keyboard. And what that does is it automatically inherits the size and the offset from the connection that it's coming from. All right, so a tip that a lot of users in Revit are aware about who have been using Revit for a while, but it's again something that is not documented at a lot of places. So what we can then do is we can route the main run in this way. And with that done, what I can now do is I can branch out to connect to these diffusers. So to branch out, what you could then do is you could just hover over the point where it highlights the diffuser, and once you see that diffuser connection highlight, you can then again just click and just as a good practice hit the spacebar again and then make the connection to the diffuser. So now it's connected. So you can see the number of unassigned items still stays the same. So creating the system is happening before we actually create the ductwork in this example, right? You could also have it work in a way where it automatically moves the number of unassigned items and assigns them to specific systems as you route the duct or the pipework. So again, we make the connection to the other diffuser, and to make the connection to the remaining diffusers, what we can do is we could just click on the elbow here, convert that to a T connection, and then route the ductwork to that diffuser. So notice that we have an exclamation mark here and an exclamation mark here indicating we have two open connections, but as soon as I make that connection, those exclamation marks go away, indicating that my connections are being made correctly. Right, so I can now convert this T to a cross again and then connect my duct to the diffuser. So in this way we have all our ducts connected between the diffusers and the VAV. Now if I select this piece of duct here and look at its flow, the flow that it reads is 0 CFM when I would expect it to read something like 200 CFM. So the reason that it's doing this is because we still have an open connection here, and Revit at this point thinks that the air is leaking out of this connection point. So what we need to do is we need to find a way to close this connection, and that can be done automatically now after 2014 by using the cap open ends button. So earlier what you would have to do is select your duct fitting, browse for the rectangular end cap in this list of fittings, and then place that end cap on this opening here. But now what you could do is you could just select the duct and you could go to cap open ends, and it will cap that open connection here. We can see the end cap here, and with that end cap in place, now if I select this piece of duct, the flow should propagate correctly and we see a flow of 200 CFM. Right, similarly this duct should read a flow of 400 CFM, and that is what we see here. And if I select this duct again, it should be 400 CFM. And finally, if we select the VAV here, the flow should update from a 900 CFM to now read 400 CFM. So in this way, if you have your systems predefined and then connect your diffusers to your VAVs, you could then propagate the flow correctly across your model. What I'll do with this example though is I will show you how you can have Revit automatically create the system and move the unassigned items and assign them to another system as you draw the ductwork. So in the first example, we first selected the diffuser, created our duct system, and then had the number of unassigned items go down. But in this case, what we will do is we will directly start with the duct tool, and I can start over here and go out in this way. Again, do something similar. So again, the number of unassigned items is not going down, but as soon as I make this connection here now, you'll see that I have 9 unassigned items, and it has automatically created a second system under mechanical. Right? If I want to know what is the name of that system, you could select your duct or diffuser or any part of that routing, and it will give you the system name. So it's called Mechanical Supply Air 2. The other way to grab that system is on the ribbon by clicking on Duct Systems. It will grab everything on that system and highlight it in your view, and then you can change the system name over here. Okay, we see that there are 2 elements as part of this system. And in a similar way, what we can do is we can continue routing our ductwork and make the connections to the other diffusers. Right, so you could come out in this way and also have connections made in this way instead of converting your elbow to a T every time. Now if I select this duct again, I see that there is zero flow propagating through it. And another tool that you could use to visually aid in this process of seeing the flow is called the duct color fill legend. And to create that legend, what I can do is I can duplicate a view and have a dedicated view that just shows me the flow across my systems. So I could just call this one mech flow. And in this view, what we can do is we could go to the Analyze tab, make sure we save what we've done so far, and select the duct legend. And I can place my legend somewhere here. So I'll call this duct color fill and flow. And now you can see that it shows you 0 CFM through these segments, right? That is the color corresponding to 0 CFM. So again, I can grab my duct here, cap the open end, and as soon as we do that, the flow propagates through that ductwork. Right, so once this is done, what we can do is we can go back to the one mech floor plan, and in this view, what you can do is you can tag your ductwork so that you see the size on your ducts, and you can choose to either have a leader or have that turned off. And one of the reasons why I'm placing these tags is because I intend to size my ductwork automatically. And before we size that, let's look at the method that Revit uses for sizing your ductwork. So there are these methods that are available when you run the duct or pipe sizing calculation. The first one being the Ashtul-Sal equation that you see here, and you see all the different variables as part of that equation. So it tells you how the friction factor is being calculated, and it has different formulas for round, rectangular, and oval ducts. You could go look at the Colebrook equation, and so you could use any one of these methods for calculation of the duct sizes. And let's suppose you want to use this equation, then you make sure that that equation is the active option selected here, hit OK. And then to size your ductwork, what you could then do is you could just hover over your piece of duct, tab, and grab the entire run of ducts that you want to size. And what you could now do is click on the duct and pipe sizing utility. So the duct pipe sizing utility will allow you to size your ductwork based either on just velocity or friction, or you could use the more complex equal friction and static regain methods. So if you go with say equal friction and set a value of 0.08 for the pressure drop, for the friction drop, and you hit OK, what it will do is it will try to size your system based on that criteria, and it will automatically change the duct sizes for you. So we can see how it's automatically running that calculation and resizing the ductwork. Again, it's not breaking any connections. In some cases, you may see that happen. So in that case, what you could do is try to readjust your layout a little bit, maybe see if you can move or reduce the length of certain segments of ductwork, and see if that gives you better results with sizing the ductwork automatically. So once you size your ductwork, what you could do is you could select your duct, and you can see that it is automatically also doing a calculation for the pressure drop. Now the pressure drop value is also available without doing the calculation. But obviously once you do the calculation, those values here are then based on that sizing parameter that you've used. Right. What you could also do is you could use some of the other analysis tools available within Revit to see how well your system is connected. So another tool that you could look at for that purpose is called the System Inspector, and the System Inspector becomes available by selecting the entire system again. So I've just hovered over a piece of duct, and your tab key as you hover and highlight it allows you to add to your selection, and you can then add to that selection and click, and you could then click on the System Inspector, and it brings up this temporary tab here, which is separate from the ribbon, and you could click on Inspect, and then it will basically show you flow lines with a red and a blue color. So if you hover over any one of them, it gives you the static pressure and the pressure loss and the flow through that segment of duct. And what you see with the red color is the system with the highest pressure drop. So you could think of that as the critical line to be used as part of your sizing. Right, so you could use the System Inspector also as part of the analysis when you analyze your system. Let's size the other system as well. So I can grab that entire system, and I could go to duct and pipe sizing, and let's go with the same criteria and see how this system sizes up. So once that is sized, what I can now do is I can actually run another tool which is called the Duct Pressure Loss Report, and this tool was introduced in 2013 Revit, and it allows you to see the pressure loss through each segment of your ductwork in your system. So when you create a duct pressure loss report, you could filter out your systems based on either just the supply or return or exhaust air, or you could see all of them. So in this case, since we just have supply air systems created, we can have that selected and hit OK here. And now in this window, what it allows you to do is it allows you to select the different parameters that would appear on that report. So this report is going to be similar to a tabulated report, and you could just double click and add parameters from the available fields to the report fields. And this can be done not just for the report summary, but you could also do it for every section. So you could go to fields here, and you have a much more elaborate list here to choose from. And you could also do it for your fittings and accessories. Right, so we'll go with these default tools here, or parameters here, and we also have the option to open the pressure loss report directly once it's created. So if I hit generate here, it's going to create that. We can give that a name, so I can save this to my desktop. And this is what your pressure loss report is going to look like. So you can see that for each section, it is giving you the flow, a velocity pressure, Okay, you can see the total pressure and you can get the static pressure based on this total pressure and the velocity pressure. And it will also give that information for each segment and give that information for all the fittings. So for the fittings, you can see that it is using the ASHRAE tables. Coefficient is obtained from the ASHRAE table, and it gives you the loss coefficient values. Gives you the pressure loss using these loss coefficient values, and then you can see the total pressure loss here. Now, a question that may come up is, how do I know what element corresponds to a particular element on this report? So if you want to see your elements in the model, what you could then do is use the element ID parameter to find that element in the model. So for example, if I want to find out this particular fitting in my view, I can just copy its element ID, and in my Revit model, I could go to the Manage tab and go to Select by ID, paste the ID here. Right, so let's try this another way. Let's just make a note of that ID. So it's 1311027, and just type that in. And then hit show, and it should take you right to that ID. It will zoom your view and take you exactly to that element and leave that element selected so that you can go and look at its loss method here and see the loss method table is SR4-2, which is the same as what we see on the report. Right, so you could use all of these tools to size your ductwork, make design decisions, also use the report to send it to individuals in your team, and then go from there as far as the design part of your ductwork goes within Revit. Right, so once this is done, what we could do is we could also look at the warnings within our system. So the no loss defined warning is a common warning that you'll find if your system is fairly large. You'll find maybe hundreds of these fittings that have no loss defined on them. So we see the rectangular cross here, rectangular end cap, T, and an end cap again. And to find these fittings, you could either click over here and go show, and it will exactly show you where that fitting is, and then you could select that fitting, and it doesn't have an ASHRAE table to reference. So what you could do is you could then go in here and specify the loss coefficient here. So I could just set it to a particular value, say it's 0.02 in this case. And now what happens is the number of no loss defined warnings goes down. So in that way you can look for these fittings that do not have any losses defined in them. And fix any warnings that show up in your system. So the number of no loss defined warnings goes down. Another tool that you could use to reduce this issue or the number of no loss defined warnings is a tool that we have developed internally. It's called the Quick Select tool, and it's a free tool which is part of the BIM project suite. And what this tool allows you to do is it allows you to select items that share a common property between them. So you can apply this filter to the project, you can apply it to just this view, or you can apply it to a selection of items within your model. And the category that I'm looking for as an example could be air terminals, and I could look for all air terminals that have the family name equal to a particular criteria. So you can set the criteria here in a similar way for your duct fittings. So these are all based on your Revit categories that you find typically in your projects, and you could look for something like duct fittings over here and look for a particular parameter to narrow down to the fittings that do not have the loss defined in them. right? So let's see how these fittings, or I should say the diffusers and the VAV works together to give you that flow value. And the concepts that we are going to be looking at apply in a very similar way to the pipe work as well. So I could select this diffuser, and if I go inside the family, this is where you can see how the connectors are being defined. So if I select this connector here, the connector is what tells Revit that this diffuser needs to have air coming into it. So the kind of air that is coming in is supply air. You could change it to any one of these available options, and it is set to a preset value, right? So that is why you are able to specify a CFM of 100 to this diffuser once it's inside the project. One thing to keep in mind if you intend to use the flow calculations within Revit is to make sure that the flow is mapped to some parameter over here. So what we did here is we select the connector, and the flow we see is mapped to another flow parameter. And this flow parameter, if we look inside the family properties, is an instance parameter because each diffuser can have a separate flow assigned to it. And similarly, what we've also done with the connector is we've grabbed the pressure drop and assigned the pressure drop to another instance parameter called the pressure drop. So since it's set to a preset in with a supply air, this would work correctly for a diffuser. Let's look at the VAV and see how its connections are defined. So within the VAV family, if I grab this connection point, we see that it is set to calculated and out. So since it's set to calculated, it is going to calculate the flow from all the diffusers and then give that value to you. And again, we see that the flow property is mapped to a supply airflow parameter. What you could also do is assign a connector description, and this is particularly useful in instances where you have very similar connectors placed on top of each other. So for example, if you have a reheat coil added to this VAV and you have the hot water in and out and they would be placed one above the other, then in Revit, in a plan view, when you pick the connector, Revit would not know whether you have selected the connector going in or the connector going out. So that's where the connector description would be helpful to a user inside the project, where it will tell you exactly what connector you want to select before you make any pipe connections to that connector. Right, so we've connected all our systems in this way, and now let's look at schedules and see how the schedule can also be used as part of analyzing your systems. So one tool that we looked at, which is quite powerful within Revit itself, is your system browser. But what you could also do in Revit is you could create a schedule for your Duct systems. So I could go all the way down, look for my Duct systems. So you could give your schedule a name. And in this schedule, let's suppose I want to add the number of elements that is part of my Duct system. I can add the system name. Let's say system classification. I move the classification up, and I could suppose add the static pressure also. So I could create this system, and I see this kind of information available for my Duct system. So there are 4 elements in my first system, and this is the static pressure. 5 elements in my second system, and this is the static pressure. What you could also do in Revit is you could embed one schedule inside another one. So I could go to edit embedded schedules here, and this option is only available for certain types of schedules. And you could check the embedded schedule option, and you could select air terminals in here as the other item to embed inside the schedule. And then you could go to embedded schedule properties and ask Revit for how many air terminals are part of my Duct systems. You could look for the family and type. So this could be useful if you have different types of families added to your system. You could ask Revit to pull the flow into the schedule. So with these parameters, what I can now do is hit OK again, and we have something like this created in our schedule. What you could also do is in the embedded schedule now, you could tell Revit to not itemize every instance, and you could have it give you the grand total here. So you would see something like this. Let's go back in there and so itemize every instance is on for the schedule, but for the embedded schedule, let's have that turned off. And so you have something like this created now. So you could create some schedule like this that will also allow you to see all the different components that make up your system. You could also perhaps embed another category in another schedule where you have the mechanical equipment added to this list. So not only the diffusers but also the VAVs that make up your system can then be seen as part of this schedule. So at this point, I would like to turn it over to Scott to talk about upcoming events, and then we could see if there are any questions that you would like us to address.
Okay, thanks, Sid. And thanks to all of you for hanging on to the webinar while we were restarting it after that brief difficulty. Upcoming webinars from CTC, we have August 14th, Display Manager for AutoCAD MEP, and it'll be presented in AutoCAD Architecture. And then August 19th, we have AutoCAD Sheet Set Manager. And then August 21st, we have parametric components within Revit. All of those are kind of fundamental tools within each respective software and would be great ones for you to see how to use some of the tools within those softwares. And then also we have Midwest University. You may have heard that this year we're accepting proposals and we're looking to have a great number of classes to offer. Last year we had 55 classes, and you can teach anywhere from a beginning entry level class to an advanced workflow or even a business process or something that you have been working on closely within your discipline. So we look forward to seeing class abstracts come in for that. And more information is available at midwest-u.com. So we'll hang on the line here for any more questions. I haven't had any come in so far. If you go ahead and follow us on YouTube at cadtechnologycenter.com or youtube.com/CAD Technology Center. You can see all of our webinars and all of our workflow videos. You can also follow us on Twitter. And if you do have a question and you didn't get a chance to ask it here on this webinar today, you can email us at support@cadtechnologycenter.com or visit cadtechnologycenter.com for future events. Thanks again for joining us today.